Hello, my name is Rob Garner. I'm a software development instructor, and today I'm going to go over the basics of Git following Chapter 2 of ProGit by Scott Chacon and Vince Drop. So this chapter in the book covers basic commands that you need to do, the majority of things you'll need to do in Git. So there's two approaches to getting a Git repo. You can either initialize a repository in an existing directory or clone an existing Git repo from another server. So we're going to try both. So I've got a directory here. I just called it Git demo. And I'm going to open this in a terminal. I already have Git installed. And so to create a repo here, what we do is we just type git init. So the git init command will create our Git repo. And you can see here that it creates this .git folder or directory, and this is where all of your information for your Git repo gets started. Normally, you don't have to do anything with this Git folder. The commands in Git take care of that for you. So this is one way for us to create a Git repo. Another way, and I'm going to demonstrate this, I'm going to delete this Git repo, and we're going to start off with using GitHub. So to begin, we're going to start off in github.com, and if you haven't made an account, go ahead and make an account at github.com, and your instructor will typically create an organization for you to add your projects to. So I'm going to use the CNM Hackerspace organization, but normally what would happen is a specific organization for your class will be created. I'm going to create a new repo in here. And so if you're going to create a repo for a class, you'll do it in an organization. If it's your own personal one, you actually can do it without signing into the organization first. And so I'm going to make this one, I'm going to call it practice repo. And you can put a description in there if you wanted. You could, for classes, make the repo private. I'm going to select add a README. This will add a default README file, and then we'll create the repo. So now this practice repository exists, and it is located in the main branch. But we are going to need this URL. So grab that URL, and then what we can do is go into our directory where we want this repo to be, and we can use the git clone, and then I'm just going to paste in that repo, and this practice repo we created is now located here. That command actually brought down the repo from what's online. It has a README in here, and this is just a markdown file. There's not much in this. You can add your comments about your repo in there. If we go back to the repository here, you'll see that you have exactly the same thing up on the server. Now you can, by default, it will create a directory using the name of the library, the folder structure that's in your library. But if you wanted to use a different name, you can add that directory name, and you can actually rename and customize what it ends up being on your machine. This doesn't change what's on the server. It just puts in a different directory on your machine if you need to for some reason. Typically, that's because you may be bringing down a second version of the library and you use a second name. So now we've got the repo on our machine. The next step is making changes and recording those changes from the repository. So we have a Git repo. We've checked it out. We have a working copy on our machine. And so what we're going to do next is we're going to make some changes to that directory and then record some snapshots of those changes in Git. So remember that each file in our working directory can be in one of two states. It can be either tracked or untracked. When we start off, all of our files will be tracked and unmodified because we just check them out. And so this is the life cycle status of our files. When we add a new file, it'll be untracked. It'll be unmodified, then we modify it, then we stage it, then we commit it. And it just goes through this cycle. In order to find out where we're starting at, we can use the git status. We need to be in the directory. So let me change directories. So I'm going to do a dir. And then I'm going to change directory so I'm in the practice repo. And so if I do a directory, we can see now that we are in this directory with the Git folder. So we have to be in the same directory in our command line as the directory where the Git repo is. And once we're here, then we can do a git status. And it tells us that our branch is up to date with origin main. That means that, and that makes sense, we just downloaded it, that we should be fully in sync. At this point, we're working on the main branch. We're going to learn about branches in chapter 3, but currently we're just going to do everything on the main branch. So let's add a file. I'm going to right click here and create a new text document. And I'm going to make this brand new text file and then save it. And now that we've added this file, let's see what it looks like. I'm going to do another git status to see how that changed things. Normally, you probably wouldn't be doing all these git statuses, but we're going to do this in order to see how things are changing. And what we see is it says we have an untracked file, newdoc.txt. So remember from that from the diagram we saw, we are here, untracked. So the next step then is we want to stage this. And in order to stage it, we need to use the get add. And in fact, it even tells you here. So we're going to say git add new doc.txt. And then I'll do another git status. And now you see that it's turned green and that this document is now staged and ready for commit. So let's add a second document in here. And I'm going to add a directory in here as well. And inside of this subdirectory, I'm going to add 2 more documents. We have 2 documents in a subdirectory, and then we have the new doc and the second doc in here. So again, I'm going to go back to I'm going to do git status. And you can see we now have the subdirectory in the second document that are untracked. Now we could write git add and put all these names in here, but what we're going to do is we're going to say git add and an asterisk. And what this says is add everything. And now you can see that everything was added. So rather than typing it each time, typically you're going to do something like this. You're going to say git asterisk, add asterisk. Now let's open up the original document, and I'm going to modify it. I'm going to save it. And then I'm going to do another git status. And you'll notice that now this went from being staged to being modified. So we're going to do another git add, and I just hit the up arrow key, and when you do that in the command line, it repeats what your previous commands are. And do another git status, and we can see that now that change has been changed. So you always have to add, and then you can before you commit. So now we have all of our changes in place. We can also do a short status -s, and it's just a shorter format. We also can do a git diff command. Notice there's no change here. I'm going to go and modify this again. And then in the subdirectory, I'm going to add another file in here. And now do a git diff. And it gives you a little bit more details on what's been changed. So we can see here, we added another document, the change that's happened. And then if we do an add star again, you notice that then once you add it, then the difference history goes away. So up till now, all we've been doing is staging and changing documents. So once we've got everything where we're ready to save a snapshot, everything's been staged, we can do a commit. So commit is really saving a snapshot. Now remember, if anything's not staged, it will not be included in that snapshot. So typically we want to use that add everything command. So we'll do a git status. And we can see that everything has been staged, and the next step is to do a git commit. And it's going to, when you do a git commit, it's going to open up your text editor if one's been configured. So we're going to put that right here, and I'm just going to put initial commit. And I will save that. And then if we do a git status, let's see where we're at. And it tells us that we're on branch main and we're ahead by one, and essentially we have no other changes. So these have all now been committed. Let's make another change. I'm going to open up and I'll save this. And I'll do another git status. And you can see that now we have this modified file. And we have this -wait. Let's see what that is. I think that was created by accident. I'm going to delete that. Okay, so now I'll do another git status. So we just have the new document that's added now. I'm going to do a git add. And we can see that now that modification we did to the new document is modified. And this time I'm going to commit. But rather than just doing a git commit, I'm going to add a -m and just put in modified new duck. So if we don't want to open up the editor and type a modification, type our comment into the editor, we can just do this. And this is really what you tend to do more often, is you use just -m. When we do that, we can see we're on branch main, and our main branch is 2 commits ahead of the origin. So right now we are making a change. We're using get add to stage our changes, and then we're doing a commit. And you can do that every time, but Git actually gives us a way of doing everything all at once. So they give us a -a option, which tells Git to automatically stage every file that's already tracked before a commit. So that allows us to skip doing the get add part every single time. So I'm going to do yet another change to my document. And you can see that now, that's modified. Normally we would add, but what I can do instead is I can say git commit -a -m changed new doc.text again. The -a is going to automatically add everything. So if I do a git status, we can see that there is no untracked changes. So this was added and then committed all at once. Now, deleting files is actually a potentially recorded action. So if you create a file and then delete it before you add it, Git won't track anything. But if you add something, if you create a file, add it, then delete it, Git will actually track that deletion. So I'm going to create a new text document. Okay, so I'm going to open this in a terminal, look at our get status. We can see that there's that new file that's been added. We're going to do a get add everything. And now it's added. Then I'm going to delete this file. And do a git status. So notice that here it was added, but here it says deleted. So this is actually a change that's being tracked right now. So I'm going to now do a git add asterisk again, see what happens. And it's actually just removed that file. So because it didn't really change the status at this point, when you do another git add, it gets rid of it. Another aspect about Git is Git doesn't explicitly track file movements. If you rename a file in Git, it doesn't store the change in name per se. It actually treats it as a deletion and then an addition. So if you were to rename this a file, we're going to see that it will create both a deleted and the old name will be seen as a deletion by Git, and the new name will be seen as an addition. So let's do a git status to see where we are to begin with. We have a clean working tree. And what I'm going to do is I'm going to rename this. And then do another git status. And you can see here, it thinks that new doc was deleted and a new one was created, which is fine. It basically is kind of the same thing, but it just treats it that way. And I think it's because that makes it simpler for it to implement. I can now do git add again. And actually, it kind of figured out that it was renamed there. That's interesting. That may be a newer feature. And then Git does give us a command that we can use to do a rename if we wanted to. If we could say git mv, and we could say renamed file.txt and rename it to renamed again.txt. And you can see that it will do the rename for you. And then if you do a git status, you can see that it updated it from, well, it used to be new doc, now it's called renamed again. So the next thing to look at is the viewing the commit history. After you've created several commits, or if your clone repository has a lot of commits, you may want to look at the Git history. And so to get the Git history, we can do a git log command. And this shows all of the commits that we've done so far. Periodically, you might want to undo things. So there's a few basic tools. You can't always undo things, so this gets kind of messy sometimes. And so the first thing we'll look at is the amend option. So this takes your staging area and uses it for the commit. If you made no changes since your last commit, then your snapshot will look exactly the same, and all you'll change is your commit message. And so this is a way of editing. So you can use the amend option to edit your previous commit message. So we're going to add a file. We're going to do a commit, then we'll add a second file, and then we'll amend the commit. And I think I'm going to commit this. Okay, so we're now starting from a fresh commit. So I'm going to add a new file. And we see there we have this file that's been added. We'll add this. And then we're going to commit and so now we just made a commit. And then I'm going to go in here and add another file. And let's see what our status is. So right now, the first one was added and committed already. So now we just have one, but and we're ahead of by 5 commits. So we're going to add this one. And we can see, okay, now that one's staged. And so now what we're going to do is we're going to say git commit amend. And it's going to open up our editor. And it's going to ask us to put in another commit message. So we'll change this to So we'll change the message. So this changes the message. And then we can do a git status. And again, it puts this wait message. I'm just going to delete that and then update to git status. And then let's see, git log. Yeah, so notice that we did this, and then we did a commit before mend. Notice that git before mend is not in here. This actually replaced that commit. So if you committed something and say, you know what, I actually want this other thing work to be added to it, you can do an amend rather than a git commit. And if you add the amend tag, it will update it'll just update the previous commit. Another thing that you might need to do is unstaging a staged file. So let's say you've changed two files and want to commit them as two separate changes, but you actually type git add and stage them both. How can you unstage one? You could do a git reset head file command, and that will unstage it. You can also unmodify a modified file. If you don't want to keep the changes to a file, you can unmodify it, revert it back to what it looked like when you last committed by doing a get checkout and then -- file. So it's important to understand when you do a get checkout that you can actually overwrite stuff that you might want to have kept. So because it's going to overwrite, it's going to get rid of all the changes. So be careful when you use that. There are also, the other things you can do is you can stash your changes too. So anything that's committed in Git can also be recovered. Things that happen before you commit may not be able to be recovered. So if you never committed it, it can be lost. So we've worked locally with our repo. The next thing is working with our remote. So we brought this repo down from GitHub. And so our repo on GitHub is the remote repository. The local repository is the one that's on our machine. And this is important because when you put a repo on something like GitHub, then you can have other people work with you that are on different machines. And so working with remotes involves pushing and pulling your changes and other people's changes to and from the remote repository. So in order to do that, we need to know how to add a remote repository, how to remove them, and then how to manage the various branches. So from our repository, I'm going to open up a terminal again, and I'm going to do git remote. And we can see we have one defined, that's origin. So that's actually the one that's on GitHub. And we can also do a git remote -v, and that shows us actually the URL for our repo. And you can see here, it gives us a fetch and a push repo. It happens to be the same for GitHub. Now, occasionally you may need to add a remote. We already have ours assigned to GitHub, but if you needed to, you can add a remote by using the git remote add command and then providing the URL of the remote repository that you might want to add. And what this does here is it assigns an alias for that. So PB is the alias for this Paul Boone repo here. So once you have a remote defined, then the next thing is fetching and pulling from those remotes. So the get fetch command goes out to the remote and pulls down all of the data that you don't have in your repo yet. So if there's any changes that have been pushed to that repository by somebody else, they'll bring them down. If you clone a repository, as we did when we got our repo from GitHub, that automatically adds the remote repository under the name origin. So that's why we had origin defined. Git fetch origin fetches any new work that's on that server. So it's important to note that the fetch command pulls data to your local repository. It doesn't automatically merge it with any of your work or modify what you're working on. It just brings out the changes you don't have. So often what may happen is someone has some changes on the same things that you are working on. You will have to do a manual merge to resolve those differences when you do a fetch. There's also a git pull command. And if you do a pull, it pulls all the changes that are from the repo, and then starts the, and then if there's any changes that are conflict with yours, it'll cause a merge to happen. And so you can use fetch or you can use pull. Generally, I think people tend to use pull. Yeah, so a fetch will only bring it down without merging. A pull will pull it down and then initiate a merge. In addition to pulling a change, you can push changes to your remotes, and you use that with the git push, and then you have to provide the remote name and which branch it's going to. So if you want to push your main branch, you would say git push origin main, and that takes all of the changes that you have on your system that aren't on the cloud system and pushes those changes to the database. So that's how everyone else in your team can get access to your changes. So let's look at our current repo. And if we look at this right now, I'll refresh this, see where we're at. Yeah, we just have the README file on our repository. But this is what we have in our repo right now. So we can see this is way out of date. So let me clear this. Git status. We can see everything's, we have a clean working tree. And so what I'm going to do now is I'm going to say git origin or git push origin main and watch what happens. So we'll push this and then we'll refresh here. And you can see now everything that all the modifications, everything that we did is now on GitHub. So this is how so when you turn things into me and you put it in your repo, this is how I end up getting it. Now, how does the git pull work? If we go in here, we can actually make changes directly on the server too. So for example, what I could do is I'm going to go to renamed again. And then I'm going to edit this. And so I'm actually editing this file on the web. And so notice the language here. It says commit changes. So this actually is doing exactly the same processes as we did in Git on our own machine, only it's doing it in the server. And so to save what we did, we actually do we commit a change. So that is no different than any other change. So now this is on the one in GitHub. And then, but if I look at this right now in the renamed again, you can see it doesn't have that change yet. So let's do this. Well, next thing we'll do is we'll do a git pull. And it's telling me that it changed renamed again. So now if I open this up, we can now see that we now have the version that we changed online. So git push and git pull is how we move things to and from the server from GitHub. So remember, just because you commit your changes locally does not mean that it's updated on the server. You must do a git push for it to be on the server and for other people on your team or me as your instructor to get your code. If you want to see more about a particular remote, you can also use the git show command. So I'll put in git remote show origin. And it gives me information. So it gives me the URLs, which branches there are, and basically just some basic information. So how does this work in practice? You've made a remote, you have your code down, you're working on it. I'm going to do a git status. We're clean and we're up to date. And so let me just do a basic demonstration of what your normal life looks like working with Git. So maybe what I do is I create a new document. And so really Git is basically this process. Make changes. Then you need to stage, then commit, which we can do with basically a git commit -a to add everything and -m for the message, right? So that's your typical command there. And then you're going to do a git push and then the branch, for example. And so that's going to be the cycle. You make some changes, you commit those changes, and then you push them. You get make some changes, you stage them, you stage and commit your changes, and then you push them. And so it looks kind of like this. I've made this document. I'm going to save it. And if we look at our Git status, that's there. I'm going to do git commit -a-m added daily process.txt. So what does this look like in practice? So I'm going to create a new document. And so your normal process is going to be make changes, add new documents, commit changes, and then push changes to GitHub. So that's our basic process. So this document I've created is a change. And if I do a git status now, I can see I made a change. I'm going to git add everything. Now that's staged. And then I'm going to git commit -a-m with my message. And branches ahead of origin main by one commit. So that's telling me that it's not up here yet. If I go look at my files, I see that normal process is not up on the server yet. So then I do a git push. And then if I refresh the web, we can see that normal process is on here. Did I not save it? Oh, I guess I hadn't actually saved the changes in that document. So we'll do it again. So the document went up, but the text had not been saved in it. So I saved it. And so I'll do a git add asterisk. We don't really need to because I think it's already there, but you can just kind of make this a normal thing you do. And then git commit -a-m and we're ahead one now, and then I'll do a git push. If I do a git status now, we can see that it's up to date. I refresh here. And we can see that that document now has all the text in it. And so that's the regular cycle. Let's say I wanted to change this and put numbers next to it. You could think of this, and if you're doing code, this would be changing your code. I save that. Yep, it's saved. And after a while, you won't be doing git statuses all the time, but I'm just doing them here so we can see what the status is. It's modified. Git add asterisk, git -a-m let's see. Okay, now we're ahead. I forgot the word commit, so now it's committed. And then I'll do a git push. Go on the server, just make sure it's there. And now we have line numbers. Maybe then I decide, you know what, I want the commands. I have my notes here. Git commit -a -m message. And then this one is git push. And then we do the same process again. This time I'm not going to do the git statuses. I'm just going to do git add git commit -a -m and it's on the server. And so that last sequence there is kind of what you typically do. Git add, commit, push, add, commit, push, add, commit, push every time you make a change. So typically you probably won't do that after every change, but you write some code, you'll make some modifications. When you're satisfied with it, that you completed kind of one stage of doing things, you'll do a commit. So I recommend doing a commit, not maybe every line of code you do, but pretty frequently. I recommend doing your kind of thinking about, okay, what am I doing right now with my code? I want to do this. When you accomplish this with your code, then make a commit and keep those commits going on the server fairly regularly. Now, one of the neat things that you can do with this is, since it's retaining all the history, you can go to your code and if you go to your branch, you can look at the activity on your branch and you can see there's all the work we did. You can see there's initial commit, there's the commit after the amend, here's some text added, here's some normal process. So here's all of the changes we did. And you can actually look at this and compare changes, and you can see what was changed relative to the previous commit. And here the change was basically adding in this file. So if you're ever wondering, what did I do or how did I get to where I am, you can do this. This is also a great way if you push regularly. If you've ever gone away from a project and come back and wondered where you were, you can look at the activity to review what you did, on what did I do on my last commit. And sometimes this is all you need to say, oh, I added the commands in, and that reminds you of where you are in a project that you may have been working for a while. So that concludes this presentation on Chapter 2 of Git. It's all the basic processes and really comes down to just that normal flow. Make some changes on your code. Do a git add, just in case there's anything new that you added. Do a commit, and then push your changes to the server. And just do that, and do that at regular intervals where it logically makes sense. Thank you very much.